Hey everybody, welcome to Algebra 1-2, Section 12-1, Frequency, Tables, and Histograms. So by the end of this lesson, you should be able to construct a frequency table, construct a histogram, interpret the data to determine if a histogram is uniform, symmetric, or skewed, and finally construct a cumulative frequency table. So let's talk a little bit about what that stuff is. So first off, a frequency table is a table that groups a set of data values into intervals and then shows the frequency of each interval. So for instance, if you're weighing something, let's say it's your work at a vet and you weigh dogs. All right, so we can take all the dogs that we've weighed and kind of put them into categories, anywhere from 0 to 20 pounds, 20 to 40, 40 to 60, you see the intervals there. And then just count up how many dogs fit in each category. And then when we put that on a table, that's a frequency table. Another vocabulary term which you're probably familiar with is range. Now, not the same thing as domain and range, but all we do for range is take all of our data, take your biggest number, and subtract the smallest number. So the largest value in a data set minus the smallest number in a data set. Okay? So let's go ahead and tackle both of those real quick. Let's construct our first frequency table. First off, we need some data. So let's say we have some scores from a test, and here they are. First thing I would want to do is go ahead and put those scores in order. So this might take a minute, but go ahead and just kind of weed through and say, okay, so here's my lowest score, then my next lowest, and kind of cross them off as you go. And anyways, I've done that. It's fairly quickly because I did it before, but there we go. The scores are in order. Okay? So that's step one of making a frequency table, is put your scores in order. Now let's go ahead and figure out what our range is. So for our range, our highest value is 94, and our lowest test score was 53. So if I subtract those, I get a range of 41. Okay, so put your scores in order, find the range. And for what we're doing in this class, we want our frequency table to have about 4 or 5 different intervals. So we're going to take that range and divide by about 4 or 5. I chose 5. Okay? So it doesn't matter whether you choose 4 or 5, just if it's easily divisible by 4, then divide by 4. It's easily divisible by 5, divide by 5. So 41 divided by 5 is approximately 8.2, and I'm going to go ahead and round that up to 9. All right, I'll always round up just because it works out better that way. So what this means is every interval is going to have 9 scores in it. So what I mean by that is if I start with my lowest score, which is 53, then I'm going to have 9 scores in there. So 53, 54, 55, 56, 57, 58, 59, 60, 61. Okay, so my first interval is going to go from 53 to 61. Now what some people will say is, wait a second, if I subtract those, 61 minus 53, that's 8. That's not right. But here's the thing. The 9, when you start the next interval, going from 53, and if you add 9 to it, that starts the next interval at 62. So if you're stuck on that number 9, don't think of it as the beginning of this interval and the end of this interval has to be 9. Think of it as the beginning of this interval to the next one is 9. Okay? So same deal. If I were to count out again, 62, 63, 64, 65, 66, 67, 68, 69, 70. Okay. Now, is it going to be pretty monotonous to do that? Yeah. So what I would do is just, if I start at 62, then my next one, I'm going to add 9 and get 71, and then just keep on adding 9 for the beginning of each interval. And then keep adding 9 for the end of each interval. So if I take 70 and add 9, I'd get 79, then 88, then 97. Okay. So don't get stuck on the beginning of the interval and the end of the interval has to be what we got right here. If that makes sense. If not, we'll work that out in class. This can be a little bit confusing until you get a handle on it. So now that we've established our intervals, let's just count how many are in each interval. So from 53 to 61, looks like there's 4 of them in there. So I put that as my frequency. For 62 to 70, looks like there's only 3. So that's what I put. And then for the next interval, looks like there's 6 of them there. Next interval, it looks like there's 1, 2, 3, 4, 5, maybe 8 of them there. And then for the last interval, there's only 4. So that's how you make your frequency table. Done deal. All right? Let's go ahead and try another one. Let's say in this case we're analyzing the winning scores of Super Bowls from 1983 to 2002. Okay, so there's a list of all of our scores. Step 1 is go ahead and put them in order. So let's do that. Step 2, let's figure out our range. So my highest score was 55, my lowest score was 20, which gives me a range of 35. Once I figure out my range, let's divide it by either 4 or 5. That's an easy number to divide by 5, so let's take that and divide by 5 and get 7. So that means each interval is going to have an interval of 7. So now let's go ahead and set up our frequency table. Our lowest value is 20, so I'm going to start with 20. And then some people say, okay, so now we take the 7, and then the 20, and the 7 makes 27. But that's not where that 27 goes. Instead, that 27 needs to go down at the start of your next interval, okay? And if we want to keep on adding 7 to the beginning of each interval, we can do that. So 20, 27, 34, 41, 48, 55. That's a good way to incorporate that 7. Now we'll do the same thing for the end of the interval. So 26, and then add 7, 33, 40, 47, 54, and 61. Okay? So establishing those intervals can be a little bit tricky, but now here comes the easy part. Let's count the frequency for each interval. So for the first interval, looks like there's 4 values. The next interval, there's 4 values. For the next interval, there's it looks like 7 values. Then the next interval, there's only 2. And then the next interval, 2. And for the last interval, there's only 1 value. And there's our frequency table. Now what we can do with the frequency table is we can use it to create what's called a histogram. So let's talk about what a histogram is. Well, a histogram is a graph that can visually display the data from frequency tables. Well, okay, well, let's take a look at what it looks like. So here's an example of a histogram. Notice what's going on here. It looks a lot like a bar graph, except it's not exactly a bar graph. Instead, what we have is each bar has an interval. So this first one goes from 100 to 200. The next one goes from 200 to 300. All right? Notice how each bar has an equal width. Okay? If you don't make each bar with an equal width, it's not an accurate histogram. Okay? That's an important part of it, is so that way when you look at the data, you know that each bar has the same width. It's got the same interval. Okay? Also notice that the bars are touching. All right? So let's compare this to, well, here's another example of a histogram. So again, the bars are touching. Each bar has an interval along the bottom. But let's compare how this looks compared to a bar graph. In a bar graph, your bars don't have to be touching. And in a bar graph, whatever you're measuring doesn't have to be numbers. It doesn't have to be intervals. So here on this one, we used months as what we're measuring. Okay? With the histogram, it always has to be intervals, always has to be numbers. Okay? So if you take a look at this, you can see the intervals. Hopefully you can see that's a little bit small. But I hope you can see the intervals there at the bottom. Notice that the bars are touching. And notice the bars are always the same width. Something else that has to happen in an Instagram, in a histogram, is that each histogram has to have a title so that whoever's looking at it knows what you're talking about. It has to have a label on each axis, and you have to have numbers on each axis. So as we construct our own histograms, we have to have the exact same thing. So if we take a look at those, let's go ahead and start constructing our own histogram. So we're going to take a previous frequency table, and we're going to start setting up ours by setting up a chart. And like I said, each histogram has to have a title. So even if it's something generic like just test scores, all right, that's the title. We know we're looking at data collected from tests. Let's go ahead and label each axis. Quite frequently, your y-axis, we're just going to call it the frequency. You know, how frequently is each interval represented? And along the bottom, we're representing the different score intervals. Okay, so quite frequently your x-axis will be something intervals, whether it's Super Bowl score intervals, test score intervals, time intervals, whatever. But it's okay to have frequency as your y-axis and something intervals as your x-axis. Next, we need to go ahead and put numbers on each one. So obviously we've got our intervals along the bottom that we're going to put along the x-axis. And it looks like our highest number is 8 on the frequency. So we want to make sure and label up to 8 on the y-axis. Okay? Well, let me see if I can squeeze my head out of here a little bit. Nah, not really. Okay. So then, now that we have our table set up with not only a title, each label or each axis has a label, each axis has numbers on it. Now let's go ahead and fill in the chart. So our first interval has 4, so we can go ahead and put that in. Then our next interval has 3, our next interval has 6, next interval has 8, and the last one has 4. And there's our histogram. Now let's go ahead and check that it has the 5 things it needs in order to make a histogram. So first off, does it have a title? Are the axes labeled? Are the axes numbered? Are the bars equal width? And finally, are the bars touching? There's no gaps between. So if we take a look, it has a title? Yes. Does each axis have a label? Yes, it does. Is each axis numbered? Yep. Are the bars equal width? Yep. And are the bars not spaced? Well, I kind of put a black outline on each purple bar just so that you can kind of see the difference between them. But really, they're right next to each other. They are touching. Okay? So we have a complete histogram here. Let's see if we can do another one. Okay, this time we're using the winning scores from the Super Bowl, the previous frequency table that we did. And so let's go ahead and set up our table. Let's give it a title. Let's go ahead and label each axis. So my y-axis is going to be frequency, and then my x-axis, again, we're talking about scores. This time not tests, but this time it's Super Bowl winning scores. So I can say score intervals. Go ahead and put numbers on each one. Again, our x-axis numbers come straight from the frequency table. And it looks like our biggest value on the frequency is 7, and we already have it labeled up to 8, so that works. So now all we have to do is start putting in those values. So our first interval was 4, and then another 4, and then a 7, and then a 2, and a 2, and a 1. There's our histogram. Now, when we do histograms, let's make sure, again, that we have all 5 parts. Does it have a title? Is each axis labeled? Is each axis numbered? Are the bars an equal width? And are they not spaced? Are they touching? Check. Check on all those. So we have a good histogram. Now, sometimes we can interpret the data from a histogram and tell whether that data is one of 3 things. Is it uniform, is it symmetric, or is it skewed? So let's take a look at examples from each thing. In order for a histogram to be uniform, pretty much all the bars have to be about the same height. Okay, so here's a pretty good example. There's a little bit of variance, but for the most part, all those bars are the exact same. So we would classify that as uniform. The next classification is symmetric. Is what's happening on one side the same as what's happening on the other? So here's a classic example of what's known as a bell curve, because this kind of looks like a bell. All right, so it's flat on either side, but then as it comes towards the middle, it reaches an apex. Okay, so it's symmetrical. What's happening on one side happens on the other. Same idea with this. Okay, it looks like I've got a peak here on the left, but also a peak on the right. So even though it doesn't look like that classic bell curve, it's still symmetrical. Lastly, what if the data is skewed? So here we've got a lot of data at the beginning of the table, but not a whole lot of data at the end of the table. So we could say that that's skewed left. Or if that's flipped around, we could say it's skewed right. Let me get my head out of there. So here you can see on the right-hand side, we've got a lot more data than we do on the left. All right. So if we go back to what we did with the test scores, is this uniform? I wouldn't say it's uniform. Is it symmetric? Well, if this first interval hadn't been there, then yeah, I'd say it's symmetric. But you know what? I'd say that's probably it. I'd say it's probably symmetric. Could you make the argument that it's skewed? Maybe, except for this interval, it's a little bit low for it to be all to the right-hand side. So if I had to make a determination here, I'd probably say it's symmetric. Okay? And again, sometimes classifying it can be a little bit difficult. This one, well, I've got a lot of data right here, but not a whole lot of data here on the right. So I would definitely say that this one is skewed. Okay? Now let's hit our last topic, a cumulative frequency table. So if we take a look at a cumulative frequency table, all it is a table that shows the number of data values that lie in or below a given interval. So here's what that means. Here we have a normal frequency table. We have our intervals right here, our frequencies. But a cumulative frequency table has an additional column for the cumulative frequency. And what happens is it just basically counts what's in that interval and everything before it. So for the first interval, okay, we had a frequency of 1. That's our cumulative frequency. So far, we've counted one thing. Now, when we move down to our next interval, okay, the first one had 1, the second one had 4. So altogether, we've counted 5 things. And for the next one, well, 1 plus 4 plus 3 makes 8. And then 1 plus 4 plus 3 plus 7 makes 15. And then you just keep adding what you've done in that interval plus everything before it. So as you can see, by the end of the table, you've added up all of your frequencies to get your grand total. All right? So let's go ahead and take what frequency tables we've done so far and turn them into cumulative frequency tables. So here's our frequency table based off of test scores. And let's go ahead and add our third column. And for the very first frequency, you just take whatever you had, so the 4, and just drag it on over. And then for the next one down, we take not only the 4 that we just counted, plus the 3 in the second interval, which makes 7. And then you can add that 7 plus the 6 to make 13. And then that 13 plus 8 to make 21. And then that 21 plus 4 to make 25. And there's our frequency table, our cumulative frequency table. Let's do the same thing for the winning Super Bowl scores. There's our frequency table. Let's add that third column. Start off with 4 in our cumulative, and then take 4 plus 4, and you get 8. 8 plus 7 gives you 15. 15 plus 2 is 17. 17 plus 2 is 19, and 19 plus 1 is 20. So that's all you have to do to make a cumulative frequency table. Not much more difficult than making the actual frequency table itself. So I hope you guys found this lesson. Once you get your mind wrapped around it, it's actually pretty easy. So we'll do all that we can to get our mind wrapped around it, but hopefully it's not too bad. Hopefully you'll find the rest of this chapter pretty doable. So if you guys have any questions, please feel free to email me, either talk to me in class or via email, and hopefully you guys are doing all right. Okay, I'll see you real soon. Have a good one.